Everyone, welcome back to my YouTube channel. As you all know that my name is Archita. I am currently pursuing my BE in Sri Venkateshwara College of Engineering, Bangalore, from the Department of Artificial Intelligence, semester 3rd sem. The subject we are going to discuss in the video, Digital Design and Computer Organization. The subject code is BCS 302. The topic we are going to discuss in the video, concept of K-map and its advantages and disadvantages of K-map. Let us discuss the contents, definition of K-map and its functions, steps using in K-map, 4-variable K-map and advantages and disadvantages of K-map, and finally conclusion. Let us firstly discuss the definition of K-map. What is K-map? The map method provides a simple, straightforward procedure for minimizing Boolean functions. These methods may be regarded as a pictorial form of a truth table. The map method is also known as Karnoff map or K-map. Let us see the functions of K-map. K-map is a diagram made up of squares with each square representing one main term of the function that is to be minimized. Since any Boolean function can be expressed as a sum of main terms, it follows that a Boolean function is recognized graphically in the map from the enclosed area by those squares whose main terms are included in the function. Map represent a visual diagram of all possible ways of function may be expressed in standard form. The simplified expressions produced by the map are always in one of the two standard form. Sum of products are product of sums. The simplest algebraic expression is an algebraic expression with the main terms, minimum number of terms with the smallest possible number of literals or variables in each term. This expression produces a circuit diagram with a minimum number of gates and the minimum number of inputs to each gate. Let us see the steps for using in the K-map. Let us see 4 steps. First step is draw the K-map based on the number of variables. Second step, fill in the cells based on the truth table, 1 for min terms and 0 for max terms. Third, identify the group of adjacent 1s for SOP or 0s for POS. Fourth step, simplify the Boolean expression by eliminating the variables that remain constant across the groups. 4-variable K-map. The map for Boolean functions of 4 binary variables w, x, y, z is listed the 16 main terms and the squares assigned to each. The map is redrawn to show the relation between the squares and the 4 variables. The rows and the columns are numbered in a gray code sequence with only one digit changing value between the two adjacent rows or columns. The main term corresponding to each square can be obtained from the concatenation of the row number with the column number. For example, the number of the third row 11 and the second column 1 when concatenated given the binary number 1101, the binary equivalent of decimal 13. Thus, the square in the third row and the second column represent the main term M13. One square represents one main term, giving a term with 4 literals. Two adjacent square represent a term with the 3 literals. For adjacent square represent a term with 2 literals. 16 adjacent squares produce a function that is always equal to no other combination of squares can simplify the function. We can see the figure 3.8, the 4-variable map. It consists of 4 variables. Solve the problem based on the K-map. First, solve S equals to f of a, b, c equals to summation m of 0, 1, 3, 5, 6, 7, 11, 12, 14 using K-map and implement using basic gates. First, draw the K-map based on the number of terms or variables. and then fill in the cells based on the truth table, one for minimum terms, and then identify the group of 1s or SOP or OS, and simplify the Boolean expression by eliminating the variables uh, at the problem. Then finally we get S equals to A bar B bar C bar plus B bar C D plus A bar B C plus A B D bar plus A bar D application. That helps in minimizing the Boolean functions easily, especially for small scale problems up to 5 to 6 variables. Second, visual approach offers a clear visual representation of the simplification process, reducing the chance of errors. Third, easy grouping. It simplifies the identification of groups of minterms or max terms for expression reduction. Fourth, time saving. When compared to algebraic methods like Boolean algebra simplification, K-maps are quicker and more intuitive. Fifth, applicable to SOP and POS. It can be used for both sum of products and product of sums simplifications. Let us see the disadvantages of K-map. There are four disadvantages: scalability issues and human error, limited to binary variables, and non-structured method. Let us discuss the four functions. Scalability issues. It becomes inefficient and cumbersome for functions involving more than 6 variables. Second, human error. Manual grouping and simplification can sometimes lead to errors, especially with more complex maps. Third, limited to binary variables. It is applicable only to binary variables and cannot handle more complex systems like multi-variable logic. Non-structured method. Fourth method. The process of finding prime implicants can be unstructured and may not always lead to most minimal solution if not done carefully. K-maps are excellent tool for small to medium scale logic minimization problems, but other techniques are needed for larger, more complex systems. Finally, we can see the conclusion about the K-map functions. Karnaugh map or K-map are visual method for simplifying the Boolean expression in digital logic design. They allow for easy identification and elimination of redundant terms by grouping the adjacent one s. This reduces the complexity of logic circuits, saving space and resources. K-maps are most effective for functions with up to 6 variables. They help to prevent errors compared to manual Boolean algebra manipulation. However, for more than 6 variables, K-maps become cumbersome and other methods are preferred. Thanks for watching this video.